happy day. I am going to give you an introduction to unified modeling language. In software engineering, we have learned that there are various phases of software development. Various phases include requirement analysis, software design, software coding, testing, and maintenance. Unified modeling language, in short we call it as UML, helps to visualize the software system that follows object-oriented paradigm. UML is a standard language for specifying, visualizing, and documenting the various artifacts of the software system. UML uses graphical notation to represent the various object-oriented functionalities of the system. UML also helps to bring the model of the system, and also it gives us a blueprint of the system. By the blueprint, I mean that on looking into the UML diagram, one can visualize the various features in the system and also will come to know how these features are going to be implemented. UML helps the developers and the customers to communicate and also to validate the software architecture. There are various tools available in order to draw these UML diagrams, but the most popular one is the rational rows, which helps us to analyze and design object-oriented software system. The various UML diagrams are use case diagram, which helps to show the relationship between use case and an actor. Interaction diagram, under this we have two types, sequence diagram and collaboration diagram. Sequence diagram helps to show the object interaction and operations between each other in a sequenced fashion. Collaboration diagram helps to display an interaction between the objects and how the objects are linked to each other. Class diagram helps to visualize the logical relationship between the classes in the system. Next comes a state transition diagram, which helps to show the various states in which a class can transit. Basically, it shows the transition between one state to another state by a class. Then we have component diagram, which helps to show the dependencies between the various components of the system. Finally, we have deployment diagram, which helps to show how the software system can be deployed in a hardware system. Use case diagram gives the abstract view of the system. It gives a functional specification of the system. It also specifies the system in a more abstract way. The various model elements that are used in the use case diagram are use cases and actors. Use case represents the functional requirements of a system, and actors are the stakeholders. Stakeholders are the one who has interest with the system. With the help of the use case diagram, one can visualize how the various functionalities of the system are included in the software system that is going to be developed. And also it shows the relationship between the use cases and the relationship between the use case and the actors. That use case diagram depicts what of a system and not how, which means that use case diagram tells the functionalities of the system and it will not tell how these functionalities are going to be implemented. This is a model use case diagram for bank ATM system. So from this diagram, we can understand that the various functionalities of the bank ATM system includes transfer funds, withdraw money, then view balance, change PIN, make payment, and deposit funds. And the stakeholders those who are going to interact with this bank ATM system are the customer, the bank official, and credit system. So on looking into this use case diagram, one can visualize the various features a system is going to have and who is going to interact with these functionalities or with these features of the system. And one need to understand that if you want to identify a particular functionality as a use case, then it should have set of tasks to be performed, not a single task, it should have set of tasks to be performed. Then only we consider that as an use case. And every use case has a set of preconditions to be followed and post-conditions to be satisfied. And also every use case will have a normal flow and an abnormal flow. Now all these specifications will be helping the developers when they write the code. That's the reason why we developed this use case diagram. The model elements that are used in the sequence diagram are the objects and the actor. So the objects represents the needed functionality that are going to be performed, and the actors are the one who is going to interact with the system. This is a model sequence diagram for withdraw money use case, which is depicted in our use case diagram. So in the earlier use case diagram, we have seen that there are several use cases like transfer funds, withdraw money, view balance, change PIN, etc. So the sequence diagram will be drawn for every use case in the use case diagram. The use case diagram will be showing only what of the system and not how, but in the sequence diagram, we will be illustrating how these functionalities are going to be implemented. So this is a model sequence diagram for withdraw money use case. So here we can see that the interaction between the objects in a sequenced manner, and also we can see how the actor can interact with the various objects. So these lines between the objects represents the messages that the objects communicate with each other, and while the software is being implemented, these messages will be converted as an operation. See collaboration diagram. Collaboration diagram is also a kind of interaction diagram. Here the communication link between the object represent that there is a communication between the two objects, and whenever there is no link between the two objects, it means that there is no communication between the objects. So basically, collaboration diagram also represents the interaction between the objects, but the presence or absence of the communication between the objects can be represented with the help of the collaboration diagram. Otherwise, both sequence and collaboration diagram are one and the same. In the sequence diagram, we represent the sequence of instructions to be followed, and in the collaboration diagram, we also show the interaction between the objects and also the presence of communication between the objects by means of a linked line. So next type of diagram is a class diagram. So class diagram represents a logical relationship between the classes in the system. So we have seen in the beginning of our presentation that these UML diagrams are drawn for object-oriented programming languages, are drawn for the softwares that are based on object-oriented programming language. So any object-oriented programming will have class as an entity. So a class will have several components. So a class in UML will be represented by means of a rectangular box like this, and this class has three components. The first one is the name of the class, second one is a set of attributes, and the third compartment represents the methods or the functions involved in the class. Now each of these attributes and each of these methods will be represented with its access specifier. Access specifier are nothing but the attributes and methods, whether they are public, private or protected variables. So these information can also be represented in a class. The class itself can be given an access specifier. So these kind of details can be represented in the class, and also in a class diagram we will show how the different types of classes are related to each other. So the type of relationship that exists in this particular example is the association relationship between the classes. So it is a bidirectional association between the classes. So apart from the association relationship that can exist between the classes, we have other relationships also, like we have generalization relationship, we have aggregation relationship, we have dependency relationship. So the classes, how they logically related to each other, that can be shown with the help of these relationships. So next is the state transition diagram. So state transition diagram will be drawn for a class in the class diagram. So it is not mandatory to draw state transition diagram for every class in the class diagram, but it can be drawn for the class that has the complex functionality or the very tough responsibilities. So what does a state transition diagram depict is that it shows the transition of class from one state to another state. So a state transition diagram consists of icons like start state, stop state and a general state. So a start state will be represented by means of a bullet, and stop state will be represented by means of a bullseye, and a normal state or a general state can be represented by means of a rounded rectangle. So every state in the state transition diagram will have entry action, do action and exit action. So entry action are those actions to be performed when the class enters the state, and do action are the actions to be performed when the class is within the particular state, and exit actions are those actions that are to be performed when the class leaves the state. Now given here is a sample of the accounts class in the class diagram which we have seen earlier. So I have identified that accounts class has the complex responsibilities, and hence I have chosen that class for which the state transition diagram is given here. So we have three states here: open state, overdrawn state, and closed state. Initially, the accounts class is in open state. From the open state, the accounts class can transmit to overdrawn state upon satisfying the condition when the account balance is less than 0. It means that when the customer tries to withdraw amount, when the balance is less than 0, the account class moves to the overdrawn state. So when a class has to move from one state to another state, it has to satisfy a condition, and we call that condition as a GOAT condition. Now, while the account class is in the overdrawn state, the action can be performed like we can intimate the customer to have sufficient balance to withdraw money, and hence the account class, after the customer deposits the money in his or her account, the account class can move on to the open state again. Now, if the customer doesn't deposit the amount, and when the balance is less than 0 for more than a month, then the accounts class will be transferred automatically to the closed state. Now, there is another reason why the accounts class can be moved on to the closed state is that there might be an initiation from the customer itself to close the account. In such case, the account class will be moved from open state to the closed state. So these are the transitions that an account class can undergo while the class is being executed in a software system. So the transition between the states are shown in the state transition diagram, which helps the developers when they write the code. Component diagram are used to model the physical aspects of the system. It shows the dependency relationship between the physical aspects of the system. So assume that we are going to develop a software in C++. So the C++ program will have these files, like it will have .exe file, .lib file, .obj file, .h file, and .cpp file. So we all know that if we have to write a program in C++, we save it as .cpp, and this .cpp will include all the necessary libraries like hash include stdio.h, conio.h. So .cpp depends on .h file for its completion of the code. And if the C++ file has to be executed, it has to be compiled so that obj file can be created. For the obj file to be created, .dll file has to be linked, and therefore your .exe file depends on so many other files. Say for example, it depends on .obj file, .obj in turn depends on .dll, and it also depends on .cpp file. So these various aspects of the system, various physical aspects of the system, and how these physical aspects are dependent on each other are shown in the component diagram. So in this example, we have atm.exe, which depends on the other packages in the ATM system, like we have cash dispenser, we have ATM screen, and we have card reader module. And the shaded portion of this icon represents the function body, and the unshaded portion in the icon represents the specification or the header file. So the atm.exe depends on packages or the functions like card reader. It depends on cash dispenser, and it also depends on ATM screen. So this is the depiction of the various physical components of the system that are to be developed. So this is what we will represent in the component diagram. If we want to deploy a bank ATM system, then we need to have a banking database server, we need to have a printer, and also we need to have a regional ATM server, and so on. And also in the deployment diagram, we not only show the various processor and various processes involved in the system, and also we specify how these nodes are communicated to each other, or how these nodes are connected to each other. So this is an example of a deployment diagram for a bank ATM system. So here we can see that how the various physical components are connected to each other. These processor and nodes are connected by means of a network. So what type of network we are going to use for deploying the system, whether it is a LAN network, MAN network, or WAN network, all these can be depicted in the deployment diagram. And also if a system is going to be attached to any device, that can also be shown. So this is a sample of how a deployment diagram will look like. So finally, I want to conclude that I have given an orientation or an introduction about UML and the various types of diagrams that we can draw in UML. So one can start drawing the UML diagrams for a software project of your own. As you start drawing the diagram, you will dig into more details on it, and you have many tools available in order to draw this UML diagram. And it is always not mandatory to use a tool to draw the UML diagram. Even you can practice these diagrams by drawing with the help of paper and pen or paper and pencil, and you can get the benefit out of it. Thank you.